Lesson 9, solve systems of equations algebraically with elimination. So yes, we have another way. We did graphing, substitution, and now elimination. Get your note packet ready. If you don't have your note packet, you're taking notes in your learning log. Get your title and learning target written down. I can solve systems of equations using elimination. And while you're at it, get the definition of elimination down. What is it? Elimination is when we eliminate or zero pair one of the variable terms so we can solve for the other, okay? So I have some steps written out that we're going to follow. You can pause this at any time. You can rewind. Take your time going through this as it's a video for you to watch. Step 1, we're going to write in standard form. So standard form is used for elimination. So if both of your linear equations in the system are standard form, you might want to use elimination. And you want to do that by lining up the like terms. So vertically lining up your x variables and your y. Is there a zero pair? There might be, but if there's not, you're going to have to make one, and that's what I'm going to show you how to do. Solve for one variable, and then once you get that, you're going to plug that into one of the linear equations to solve for the other one and get your ordered pair. All right, so here we go. My first example is 21x minus 4y equals 20. That's our first linear equation in the system. And then 2x plus 4y equals 3. And you might have to change that in your note packet. This should be a 3, okay? And that is the second equation in our system. All right, so you might notice they're already both in standard form. Good. The variable terms are already lined up vertically, x over x, y over y, and our constants on the right of the equal sign. Okay. Is there a zero pair? Look at your x terms. Look at your y terms. Would any of them together make 0? Yeah, we're lucky. Oh, this first example, it's in standard form. There's a zero pair. Couldn't be any easier, right? Just you wait. All right, so we see a zero pair with our y terms. We have a positive 4y and a negative 4y. Those would zero out. All right, and then we're just going to vertically do the math for what's left. A positive 21x and a positive 2x. That gives us positive 23x's. And on the right of our equal sign, a positive 20 and a positive 3 give us a positive 23. One-step equation. To solve for 1x, you divide by that coefficient of 23 on both sides. So x is 1. Remember, this is an ordered pair. So put that as your x coordinate. All right, so we've done steps 1, 2, and 3. Now we're on to step 4. We're going to take that solution of x and we're going to substitute it in to one of the equations in our system. I'll just choose the top one. So we have 21x minus 4y equals 20. And I'm going to take what we got for x and substitute it in for x. Then I'm going to do all the lovely math to solve for y. 21 times 1 is 21 minus 4y equals 20. What do we have here? We have a two-step equation. You know how to do this. Zero pair the constant. Positive 21 makes a zero pair with negative 21. Make sure you have one of each, a positive and a negative. This is a negative 4y. Don't be dropping your negatives. And 20 and negative 21. That's a battle. So you subtract them and that leaves us with negative 1 because negative 21 is a greater distance from 0. All right, to solve for y, we have to divide by the coefficient of negative 4 on both sides. So y equals a negative and a negative in that fraction make it a positive 1/4. Can we get a rational number as part of our ordered pair? Yes, it's perfectly fine. So on the graph, if we were graphing these lines, they would intersect at point 1, 1/4. You would see that point of intersection on those lines. Do your check where you would substitute each point in the ordered pair into both equations to make sure it's true. I'm going to show you on this first one, and then I'll just remind you on the other examples. All right, so we'll do the first equation first. Substitute 1 for x and substitute 1/4 for y. And if our math works out, the left side should equal 20 because the right side says 20. All right, we know this is 21. And what's 4 times 1/4? Well, you put 4 over 1. You can do your cross simplifying. That's 1, right? And 20 minus 1 is 20. So it worked in the first linear equation of our system. Let's see if it works in the second one. So now we're going to do 2 times 1. I'm just substituting that ordered pair in for x and y, plus 4 times 1/4. And that should equal 3. This is 1/4. 2 times 1 is 2. 4 times 1/4, we just did that above. That was 1. 2 plus 1 is 3. Oh, look, it worked. Hooray. So this is our point of intersection, or the solution to the system. Let's look at a couple more examples. All right. Same steps written out, okay? If you want to write them again, you can. If you have the note packet, they're already there for you. All right, so look at our system. 4x minus 3y equals 16. 2x minus 3y equals 8. Hey, they're both in standard form. Thank you. All right, are the variable terms lined up? 4x over 2x, negative 3y over negative 3y, and then the constants. Yep, we're good. Step 1 and 2. Check, check. Oh, actually, we didn't do step 2. Is there a 0 pair? Well, 4x and 2x, no, they don't have the same coefficient opposites. Negative 3y, negative 3y. Now, they're both negative 3, but we need one of those to be positive. So here's how you make a 0 pair if there isn't one. To make one of these into a positive 3y, we're just going to choose one of the equations in the system. I'll choose the top one. And I'm going to multiply everything in that equation by negative 1. So it becomes a negative 4x times a positive 3y equals negative 16. I just distributed a negative 1 to each of those terms. My second equation in the system I'm going to leave just as it is because now I have that 0 pair. We made one. Okay. Now we're going to solve for the one variable that will still exist, which will be x. Negative 4x, positive 2x, that's going to be a negative 2x. Negative 4 is greater distance from 0. Negative 16 and a positive 8, that's also going to be a battle where we subtract. And it's going to be a negative 8 because negative 16 is a greater distance from 0. Divide both sides by the coefficient of negative 2. Take that negative with it. And you get x equals positive 4. A negative divided by negative is a positive. All right, so we've got the first part of our ordered pair, positive 4. Now, we need that y. Oop, wrong color. So I'm going to take my 4 and substitute it into one of the equations in the system. I'll just do the top one. When I do the substitution, go back to that original equation before you distributed the negative 1. That's a 3. 3y equals 16. All right, so 4 times 4 is 16 minus 3y equals 16. We have a two-step equation. Think about what you do. You got a 0 pair the constant. The constant's positive 16, so we're going to do negative 16 on both sides. Yep, that makes 0. Negative 3y equals positive 16 and negative 16. We have a 0 pair on the right, too. That's all right. Put that 0. Okay, don't lose the fact that you still have an equation. Something can equal 0, right? We divide by the coefficient of negative 3. Y is going to be 0. That's okay. When we write this ordered pair, we actually see that the point of intersection is an x-intercept. It's where the lines will meet on the x-axis. Intercepts can be the point of intersection, so that's fine. So you can get a 0 for one of your variables. All right, and then you would take this solution and test it in both those equations of the system to make sure that they make them true. We've got one more example. 5y plus 3x equals 6, and 2y minus 4x equals 18. All right, are they in standard form? Yeah, I mean they are. The y term comes first though, and that's okay. It comes first in both of them, and so the like terms are lined up, so we're good with that. Is there a 0 pair? 5y and 2y, no, not the same and opposites. 3x and 4x, well, there's a positive and a negative, but it's not the 0 pair in coefficients. They're different coefficients. All right, so we have to make a 0 pair. And in this one, the new step is to create a 0 pair. Think of the least common multiple between two of the coefficients. So we can focus on eliminating the y's or the x's. Now, I'm going to choose the x's because the x's already have one positive and one negative. Okay, so that will make a 0 pair when I find whatever the LCM is between 4 and 3. And the least common multiple between 4 and 3 is 12. So to get this to be a positive 12x on the top equation, I've got to multiply that entire linear equation by 4. So I'm doing 4 times 5y, 4 times 3x, and 4 times 6. Now, in the second linear equation, to get this to be a negative 12x, I've got to multiply that whole linear equation by 3. So I'm going to do 3 times 2y, 3 times negative 4x, and 3 times 18. All right, let's see what our new then equations look like for this system. So our blue one becomes 20y plus 12x equals 24. And our gold one becomes 6y minus 12x, there's our 0 pair, equals 51, 18 times 3. Okay, we made our 0 pair. Woo! Now solve for y. We're solving for y this time. So 20y and positive 6y make 26y. And 24 and negative 51. Wait a minute, it's not 51, Mrs. Benoit. It's 54. Maybe next time I should do my side math. You're probably screaming at me the whole time. It's not 51, it's 54. It's 54. Okay. Should have done my side math, but I caught it. All right, so 24 and 54 make 78. All right. I'm going to divide both sides by the coefficient of 26. How many 26s go into 78? It's 3. And I could do that long division. I could do that side math. Do it over here. 78 and 26. 3, because 26 times 3 is 78. Okay. So I've got my y, right? So when I write this ordered pair, we're used to putting the x in first. We seem to always get x first. But sometimes you're going to get y first. Make sure you put it in the right place. All right, and now I can use that y to find my x. So I'm just going to go back to my original first one. 5y plus 3x equals 6. And I'm going to substitute in for y there, the 3, to help me solve for my x. 5 times 3 is 15. 15 plus 3x equals 6. A two-step equation. Zero pair your constant on both sides. I'm running out of room, so I'm going to go over here. 3x equals positive 6 and negative 15 is a battle. And that will be negative 9 because negative 15 is a greater distance from 0. Divide both sides by positive 3. And so then you get a negative 3 for your x. So the point of intersection for this system, if we graphed it, they would meet at negative 3, 3, which is in quadrant 2, right? And then you can check this point in both linear equations to make sure it makes them true. All right, let's practice.